Hello guys, how are you? This is Hansa here once again. In this video we'll be looking at center of mass. We'll define center of mass and also look at determining center of mass for regular objects. So let's get started. Well, center of mass is a point where mass of a body seems to be concentrated. So when you have an object, its center of mass is where its mass seems to be concentrated. Underline the word seems, where it seems to be concentrated. Here we say it coincides with the center of gravity, which is a point where weight acts, right? So let's look at these regular objects and determine their centers of mass. Let's call this one A, this one B, and this one C. So how do we do that? By inspection we can try, but the best way is to draw lines. I'll show you. Let's start with A. If I draw a line from this point all the way to this point, then another one here from this corner to this corner, yes. Then for this one I have to draw a diameter. A diameter is a line which passes through the center, right? This is a diameter, and then from this point all the way up to here, right? Then for C, from this corner through to this corner, and then from here, I can even do it this way, still okay. So here are my lines. So where these lines cross, that's where the center of mass is. For A, they cross here, so this is my center of mass. For B, here is where the lines cross, so this is our center of mass, CM. For C, they cross here, CM, for center of mass. So as you can see, we are saying for objects with uniform density and regular shape, the center of mass lies at the center of that particular object. So regular shape with uniform density, the center of mass is at the midpoint. So here's another interesting thing about center of mass. Center of mass can also be outside the body of an object. Here is our two objects demonstrating this statement. Call this A, call this B, right? This is a ray. Much like this circle, the center is here, and where the center is, that's where the center of mass is. Center of mass. And remember, if we draw a straight line through the center of mass, the two sides will be equal, like this. You see? So this side you can call it X, this other side call it Y. So these two sides are equal. They are equal, right? So if we look at this diagram B, we see that some portion of this ring in A has been removed. So that has to shift the center of mass, the midpoint. So initially the center of mass was here, right? That's where it was, but we removed some part of this ring on the right hand side here, right hand side here. So to do that, we have caused to end up with a, okay, let me do this. So initially these two sides were equal, x and y, but after removing this portion, these, they are no longer equal. Clearly y is less because we removed from side y, and to balance we have to move to the left a little bit. So center of mass will be somewhere here, so this is now our center of mass. See, this is our center of mass. We removed some parts of the ring on the right, so the center of mass shifted to the left. If we were to add, maybe if we came here and added some, maybe say a boss stick here, if we add a boss stick here to the right, the center of mass will shift to the right to try to balance, to try to give left side a little bit more so that it balances. It's kind of sharing the mass which was added, right? So if we look at this ruler now, we see that it is from 0 to 10. This is a 10 centimeter rule. Supposing this rule is of uniform density, we see that the shape is regularly shaped, right? It's regularly shaped, and for the density to be uniform, it means it is made up of the same material and same what? Thickness. So where will be our center of mass? At the midpoint. Where is the midpoint? 5 centimeter mark. Here is the 5 centimeter mark. So the center will be here. Because the center is here, this is our center of mass at 5 centimeter mark. So that's it about center of mass for regular shaped objects. So our next video will be looking at determining center of mass for irregular shaped objects. So with these ones, which are regular shapes, we can determine the center of mass by balancing. The point at which you are able to balance the object, it's where the center of mass is. Okay, so that's enough with center of mass for regular objects. Thank you.